Hi, this is the video lesson for Chapter 22, Digital Imaging Processing Operations, which basically what this chapter is talking about is the manipulation of the image data that comes from the image receptor and by the computer and how it is processed. And that begins with pre-processing, which means the raw data, as it says here in the book, the raw data has to be processed, pre-processed, before anything else can be done to it. And that first step of the pre-processing operation is called segmentation. And that is essentially where the image is partitioned off into segments, and the computer attempts to analyze it and recognize, like when there's multiple views and so forth. And in order to do this, it essentially needs to have the image shown in a symmetrical fashion, as it was back here on page 282, where it told you that this was the proper image alignment if you did multiple views on one cassette. Or if you just do one view on a cassette, then it needs to be centered and square in the middle of the image receptor. So that is essentially what segmentation does. And then exposure field recognition is where it takes the type of anatomy, whether it's lung fields or bone density fields, and attempts to compare it to the data that is in the ideal image and make so it can recognize what the image should have been. So if that's important, that if you're going to shoot a chest x-ray, you analyze it underneath the chest x-ray at the automated exposure control and the APR, where you can choose the automated program software at the control panel. And the computer then, you want to make sure that you're not taking an ankle x-ray and running it as a chest x-ray, because then the exposure field would not be recognized properly. And this exposure field is also very important that you have your borders collimated to the smallest area possible, or you'll have unwanted densities within the recognized area of the exposure field. That leads us to the next thing called histogram construction. And a histogram is just a graph of the image data, the brightness levels and the gray shades and so forth that are seen in the image. And the computer takes that and constructs a graph of it that looks something like this if you looked at it in the computer. And this shows a chest x-ray, as you can see here. And the points to the left are called S1, and the points to the right are called S2. And S1 represents points that are more white in color, have low values of density and or intensity or signal strength. And that would be like where very little x-rays actually reach the detector, which lies like over areas of bone or underneath areas of bone on the image receptor where no x-rays got through. Whereas the S2 values are representing the darker areas of the radiograph, which are like your lung fields and so forth, or further to the right. So over here's the dark areas on the radiograph, and over here would be your light or white areas of the radiograph. Okay, and it shows down here what would happen with a lead apron. As you can see, the shield would be like even more dense than bone in terms of whiteness, okay, and would be white on the radiograph, more so than bone, and would lie even further to the left. And this would skew. If your shielding ended up showing in the radiograph, it would skew the data set and cause an error in histogram analysis. This is the background area, like where you would show too much of the black surrounding the anatomy in the collimated area, like where you show the outside area of the body. And that would also skew the histogram analysis because of the high density in terms of darkness areas that would show up on the radiograph. Okay, and here is the result of scatter density showing up there on the radiograph as well, which leads to an error in histogram analysis. The histogram analysis occurs as the computer takes the data from lookup tables, which are the history of the ideal image for the exam you chose at the APR at the control panel. APR again means automated pre-programmed radiography. So if you choose a chest, the computer will expect to see a chest and will look up the table values for an ideal chest x-ray and compare them to your image, or for an abdomen, or for an extremity, or whatever it is you're supposed to be shooting. So make sure whatever you shoot in your image that is what you have chosen at the APR for the computer to analyze from the lookup table, or else you will have a histogram analysis error. Like for here in histogram A, this is illustrating the application of a bone density radiograph, and the volume of interest is underneath the left side to the center and to the left of the histogram, which this is where it expects to see the region of interest. If you were shooting like an extremity, this would be the result. If you were shooting a chest x-ray, it expects to see the histogram shifted more to the right, to the center and to the right, where you would see higher densities, primarily in the lung field of darkness, of dark areas. When I say higher density, I mean of darker areas in the radiograph. There are two basic types of lookup tables. One is called type 1, and then on the next page they talk about type 2 and also type 3. And I'm going to let you read the rest of that and look at it for yourself. I'm not really going to, I don't think it's significant enough or important enough to spend any time on explaining. All right, and then moving on to the next thing, the rest of the pre-processing that occurs, the first part is called, or the next part is called normalization. And this is where the initial image has gray levels and brightness levels that are still called raw data that must be normalized to make them appear like a radiograph should look in terms of brightness level and also in grayscale contrast level. And contrast is the difference in the grayscale from light to dark, and brightness is the center of the grayscale, the midpoint of the densities. We learned that back in the previous chapters. All right, so this is also, normalization is also known as gradient processing, refers to making simple adjustments to the brightness, the midpoint of the grayscale, and the contrast, which is the length of the grayscale from the lowest brightness level to the highest brightness level seen in the image. The gradient processing is also known as normalization, and essentially the first part is rescaling the image brightness. This is done automatically as part of the pre-processing functions of the computer, and rescaling to match the ideal image's ideal brightness level for your image. And then the next one, this is showing here moving the new image which you shot, your image, comparing it to the lookup table for the ideal image, and if they don't match as seen here, then the computer will rescale them so that they do match to what the ideal image should have been based on the anatomy you chose at the APR. And then that's also done, that rescaling process is also done for the contrast of the image, as well as what we just saw for the brightness, to make the contrast of your image look like the ideal contrast should look like. And this is done through a process called dynamic range compression, where the far ends, the upper end of the light areas, or the dark areas on the radiograph, which would be the S2 areas that are really, really dark. And then it takes the really, really light areas, which would be on the S1 end of the histogram, and it attempts to merge those or lower each of the ends and move them toward the center to where they match the ideal image more appropriately. And all of that process, both for the normalization or gradient processing of the light end S1 as well as the dark end S2, moving those toward the center, is known as automatic rescaling of the image data. All right, and then you have, after that pre-processing functions are done, you have post-processing functions where the image can be manipulated in various ways, like to enhance the quality of the image. And the first way is known as windowing, and this is where you make slight adjustments to the brightness level or to the grayscale level to please your eye by moving the mouse control or by clicking on up or down arrows. You do this yourself as a technologist, or the radiologist would do it, to make the image look better post-processing after the pre-processing is over and the image appears on the screen. The first type is known as edge enhancement, where the edge of the image is enhanced, and along like bone detail, along with soft tissue, it would make the edge look better by improving the spatial frequency seen in the image, spatial location, which is recorded detail. Then you have smoothing, which is bringing anatomy that has similar tissue densities, like in the abdomen, liver, spleen, gallbladder, intestines, bringing those closer together by allowing the low differences in gray values to merge, called low-pass filtering. And then the unsharp masking attempts to take blurred areas of the image and make it look more smooth. Then the operator adjustments, things like annotation you can do, putting left and right markers